Hello, please unmute your all audios. Please unmute your mic.
خليه مالك ترواي.
Hello, hello everyone. Am I audible to you? हॅलो, अरे माझा आवाज ऐकू येतो का?
Yes, sir.
Please reply with your please reply with your mic as well as your chat box.
Okay, sir.
Yes, sir.
We will start our lecture within 5 minutes because still students are joining this meeting. Right now 18 members are there in the meeting. Still we are waiting for some few members still who are not admitted. While lecture, please mute your all audios. Okay, can we start or we should wait for some time for students who have not still joined this meeting? Okay, still some students are joining, so that's why I'm not started the lecture yet. Now total 24 members are there in the meeting. Please ask your friends for joining this meeting.
Okay.
Please unmute your all audios. Okay, can I audible? Okay, we will start our lecture. So this is a synchronous reluctance motor. So this is nothing but your fifth topic. Actually, it's a topic name is about the fractional horsepower motors. Okay, so this basically this fractional horsepower motor are related with the single phase machines. Already in the syllabus, this syllabus related with the AC machine. So in the syllabus, we have seen about the three phase alternators, single phase induction motor, three phase induction motor. Okay, so similarly for this lecture, we will see about the fractional horsepower motors. Okay, so we'll start one by one. The synchronous reluctance motor is an electrical rotating machine that converts the electrical power into mechanical power. Please don't share your screen. काही लोक maybe screen ला edit करतायत. Because of this only it has some disturbances on the screen. Okay, please, the recording is going on, so please don't disturb the screen. Okay, whoever made this, please make sure that you are not doing same thing again. जे कोण आता हे स्क्रीनला शेअर करताय किंवा स्क्रीनला एडिट करताय, प्लीज डोंट डू इट बिकॉज एव्हरीथिंग इज गोइंग ऑन रेकॉर्डिंग. Okay, so the synchronous reluctance motor is an electrical rotating machine that convert the electrical power into mechanical power. Okay. That means, as you know, that motor which converts electrical energy into the mechanical energy. Hence, the name is given as a synchronous reluctance motor. Now, actually before going to this detailing about the synchronous reluctance motor, we will see about the reluctance motor. Okay, so the torque developed in the motor due to the difference in reluctances is called a reluctance torque. Okay, actually what will happen whenever, as we know that when we give supply to the any stator side, obviously the torque is created. Okay, that basically these torque are called as an electromagnetic torque. But for this particularly the reluctance motor, the torque is exerted, torque is produced because of only reluctances. Okay, reluctance means what? Maybe it is covered in the basic electrical or some previous year subjects. The reluctance is nothing but it is opposition to the flow of fluxes. Okay, or we call it reluctance. It is opposition to the flow of fluxes. It's a part of magnetic circuit. So here, this particularly in this type of motor, the torque is developed in the motor due to the difference in reluctances is called a reluctance torque. Okay. Now, a synchronous motor in which only the reluctance torque is developed is called a synchronous reluctance motor. Okay. Normally, the motors set or all motors are operating on the electromagnetic torque. That means we are giving electrical supply to stator, the flux is produced, and hence the torque is exerted according to the Faraday's law. But for such type of reluctance motor, the torque is exerted only or torque is produced only because of the reluctances. Okay. Now, this particularly torque is developed because of reluctance, and hence this type of motor we call it as a reluctance motor. The name is given as synchronous reluctance because this reluctance type motor are rotating at a synchronous speed. A simple called as a synchronous motor in which only the reluctance torque is developed is called a synchronous reluctance motor. म्हणजे मी काय सांगितलं, रिलक्टन्स मोटर मध्ये जर रिलक्टन्स टॉर्क क्रिएट झाला किंवा ज्या मोटर मध्ये रिलक्टन्स टॉर्कच क्रिएट होतोय त्या मोटरला generally we called as a reluctance motor. Okay, so here what will happen if this particularly motor as it's running at a synchronous speed, we call it as a synchronous reluctance motor. Now we will see the construction of synchronous reluctance motor. Now, as a construction and a production process, this synchronous reluctance motor, the SRM, is similar to the induction motors. Okay, so only the rotor design has a significant difference. SRM rotor is unsymmetrical. Unsymmetrical means काय simply आता आपण बघितलं की this is nothing, this part of the stator. Okay, so this stator, as we know that the stator of this particularly winding is similar to that of your induction motor, but the only Parth, please unmute your audio. Okay, so basically this the construction of the synchronous reluctance motor is similar to that of an induction motor. Okay, only difference is that it is a part of rotor. Just construction induction motors are same. Normally we are placing the stator winding in the different stator slot. This is stator core, the outer frames are there. Only difference is that the rotor is not the symmetrical unsymmetrical. Symmetrical म्हणजे काय पूर्ण तुमचं एक संध किंवा पूर्ण सेम साइज किंवा सेम स्लॉट साइज. Okay, now the mechanical construction of the rotor seems to be quite simple since it does not require aluminum or copper casting or magnets assembly. That means what? So as we know that induction motor has a rotor which is normally we called slip ring induction motor or squirrel cage induction motor. So it generally has a copper bars or simple called as a magnet or simple called as a different aluminum bars or copper bars, or simply we call the windings are there. But for this synchronous reluctance motor, we don't have any type of winding or any type of magnets. Okay, but it is designed is complex due to the particular shape of the rotor slot that must be keep necessary robustness with the minimized connection sectors between the rotor poles. That means what? We can see that particular structure. There is no any type of winding or there is no any type of magnets are there. Okay, so basically there is a only difference between the reluctance motor and induction motor is that it is a difference only with the rotor side. म्हणजे फक्त रोटरच यामध्ये फक्त बदलते, everything is similar. Now As construction and production process, the synchronous reluctance motor is similar to the induction motors. Only the rotary design has a significant difference. Okay, so I have prepared this particularly slide for you. This is nothing but we call it a we call this as a part of induction motor. Okay, so we call this is a construction side of induction motor, while this is the construction part of a synchronous reluctance motor. You can see the difference. Okay, now for this induction motor, we call it asynchronous motor. The rotor has a several identical slots. This particular rotor has a several identical slots with the same dimensions and shape and symmetrically distributed. Now we can see that for induction motor, everything is symmetrical. Everything is having an identical slot, or we call it as the same dimensions and shape. But for synchronous reluctance motor, the rotor has identical sectors with the several different slots with different dimensions and shape and not the symmetrically distributed. That means for this rotor, we call this. I said whatever I said. The only difference is in the reluctance motor is having a rotor side. म्हणजे फक्त रोटरला थोडं तुमचा difference. म्हणजे rotor it is there is only difference of rotor construction only. Okay, so here the rotor has identical sectors with several different slots. म्हणजे हे जे दिसतं तुम्हाला हे पूर्ण आहे. Here no any windings are there. Here no any aluminum or bars are there. Just this particular reluctance motor has a different dimension slots. Okay. Now we will see the working principle of the synchronous reluctance motors. So as I said, the reluctance motor operates on the reluctance torque. Okay. So because of the magnetic design of the rotor has areas of high reluctance, which are shown by the white areas, and areas of low reluctance, we call it the blue reluctance, the blue color. Okay. The reluctance is a magnetic resistance and it's opposite of the permeance. Okay. Flux law, the reluctance is simple, as we know that the reluctance is nothing but opposition to the flow of fluxes. Okay. Now the rotor reluctance depends from the empty areas present on the rotor laminations that creates a kind of magnetic barriers where the flux find high resistance to flow. Simply काय इथं बघा, this is part of rotor. Okay, when I give supply to the stator side, then what will happen? The flux is created in the rotor side. Okay, but as I said, there is no any winding in the rotor, so this rotor is rotated with the help of the reluctance torque. Okay, now this reluctance torque, how we are creating, how this reluctance torque will be produced, we will see for this figure. Okay, so here once the stator current is flowing through the stator side, the flux is produced. Now because of the flux, as we know that flux always passes through the low reluctance path and it opposes by the high reluctance path. So by this figure I have shown this particularly white areas which has a high reluctance, while this particular blue color side we call the low reluctance. Okay, म्हणजे काय होणार, जो फ्लक्स आहे तो फ्लक्स काय करेल तुमच्या रोटर मध्ये फक्त या ब्लू साइड किंवा ब्लू कलर आहे त्यातनच फक्त पास होणार आहे, बिकॉज इट हॅज अ लो रिलक्टन्स. रिलक्टन्स म्हणजे काय, अपोजिशन टू फ्लो ऑफ फ्लक्सेस. ओके, so the fluxes only passes through these particularly blue areas, while the fluxes are restricted or fluxes are made opposition by reluctance on the particularly these white areas. Okay, now I have shown once this particular high magnetic reluctance and low magnetic reluctance. Now what will happen, because of the fluxes which is produced because of the difference in the reluctance, for this blue color reluctance, for the blue color the reluctances are very low, for white color reluctances are very high. So because of the difference in between the reluctances, the torque is exerted. Okay, and now this figure shows the high magnetic reluctance versus the low magnetic reluctance. So this particularly red color indicates low magnetic reluctance, that means particularly blue color, and this white color has a high magnetic reluctance. Now this working principle. Now when the stator windings are excited, a magnetic field is generated. Okay, and the rotor aligns to its most magnetically conductive axis. Please unmute your audios. When the stator winding has excited, a magnetic field is generated and the rotor aligns its most magnetically conductive axis. म्हणजे सिंपली काय, जिथं तुम्हाला रोटर तुमचा जो रोटरचे पोल्स आहेत किंवा रोटर तुमचा ऍक्सिस तो काय करणार आहे, जेव्हा स्टेटर वाइंडिंग तुम्हाला जेव्हा तुम्ही स्टेटरला सप्लाय देताय, इन दॅट केस व्हॉट विल हॅपन, द रोटर इज अलाइन्स. रोटर म्हणजे रोटेट मूव कुठं होणार आहे, वेअर द मॅग्नेटिकली कंडक्टिव्ह, म्हणजे जिथं लो रिलक्टन्स पाहिजे त्या साईडला तुम्हाला रोटर तुमचा अलाइन होणार आहे with the applied field in the order to minimize the reluctance in the magnetic circuit. Now The synchronous reluctance motors are engineered intentionally with identified sectors depending on of the nearest of the poles, and are made with the magnetically conductive materials, which is nothing but iron material, and magnetically insulating material, that is air. Simply what will happen, as I said, the synchronous reluctance motor operates on the reluctance principle. Reluctance principle, that means what? So whenever there is a reluctance torque is created, and then only this particular motor will start rotating, because once the reluctance torque is generated, now the motor is start to rotating in the rotor side. Okay, so basically we are going to see the working principle. Now when I give the supply to the stator side, you can see that particular figure. हे जी figure है. Okay, so this diagram, it is part of rotor. हा पूर्ण rotor से हमारे just I'm providing this particularly AC supply for the stator side. So जेव्हा मी स्टेटरला सप्लाय नंतर काय होणार आहे, इथं जो तुमचा मधला हा जो व्हाईट कलर आहे, ओके, दिस पर्टिक्युलरली दिस वी कॉल्ड एज अ लो मॅग्नेटिक परमियाबिलिटी, and this one we called as a high magnetic permeability. Okay, so permeability, as you know, it is the ability to passing the flow of fluxes. म्हणजे permeability simple काय, जर फ्लक्स पास करण्याची क्षमता आहे. ओके, और permeability is the ability, म्हणजे resistivity, conductivity, जसं permeability. Permeability is a property of material which is allowed to pass the fluxes. Okay, that means now because of the difference in reluctance, you can see that now इथं काय होणार आहे, इथं low magnetic permeability म्हणजे काय, इथं तुमचा basically this part is having this one. Okay, this is having the high reluctance part, while the particular this one blue color indicates the low reluctance part. So because of these two only, the torque is exerted on the rotors. Now this is the actually this is torque speed characteristics. So this particularly the torque characteristic is drawn in between the output power versus the torque. Okay, so this will be drawn according to the output power which is in watt and torque which is in Newton meter. So basically the advantage and application of synchronous reluctance motors are, advantages are the no electromagnetic losses, because as we see in the induction motor there are obviously the loss, obviously there is a windings are there. Shreyas, please don't do any screen sharing here. Screen वरती काही edit करू नको Shreyas. Now there is no electromagnetic losses are there compared to the induction motor. Mechanically strong because there is no any part of windings are there. Inherently reliable because there is no the fault occurrence or the reliability factors are more. Simple in construction, cheaper in cost compared to induction motor. It has a high efficiency because there is no any windings, so I2R losses are minimized, and it has a robust construction. So basically these motors are used in the pumps or conveyors, synthetic fiber manufacturing industries, wrapping and folding machines, nuclear reactors, synchronized textile drives, processing of continuous sheet or film materials, and constant speed applications. So basically these synchronous reluctance motor, as you know, the synchronous reluctance motor operates for synchronous speed. So basically these machines or motors, they are basically for a constant speed applications. Now we will see about the switched reluctance motor. Okay, now the switched reluctance motor SRM is also known as a variable reluctance motor. Previously it was a synchronous reluctance motor. The second part of the switched reluctance motor, this part is also known as a variable reluctance motor. Now this motor works on the principle of variable reluctance. Okay, this means the rotor always try to align along the lowest reluctance path. Now this means the rotor always tries to align. Align means rotate or change. Now the rotor always tries to align along the lowest reluctance path. As the name suggests, a switching inverter is required for the operation of switched reluctance motor. Rushikesh, please don't share your screen. As the name suggests, a switching inverter is required for the operation of switched reluctance motors. Now we will see the construction of switched reluctance motors. The variable reluctance motor or switched reluctance motor has two different constructions. Okay, so firstly we call it a singly silent construction, and second one doubly silent constructions. Now the stator and rotor magnetic circuits are laminated to reduce core losses switched reluctance motor. I am requesting to all, please unmute your audios. Rushikesh, please unmute your mute your audios, please. Rushikesh Ekate, please mute your audio. Okay. Now, basically this switched reluctance motors are two types. The classification is made according to the construction part of the stator. Okay. The motor is classified into two types. We call it singly silent construction and doubly silent construction. Okay. And similarly, the stator and rotor magnetic circuits are laminated to reduce the core losses in both type of switched reluctance motors. Now, we will see about the first, about the singly silent construction motors. Okay, so this part, okay, so this part we call it a singly silent. Silent म्हणजे काय? Cylindrical pole and silent pole rotors. Okay, now a singly silent construction of switched reluctance motor consists of a non-silent stator and a silent two-pole rotor. Non-silent म्हणजे काय? तर तुमचा symmetrical type stator असणार. Symmetrical म्हणजे तुमचा गोलाकार शेप. ओके, आणि silent pole म्हणजे तुम्हाला माहित आहे की silent pole म्हणजे अशा टाइप मध्ये. दिस वन. ओके, हा जो पूर्ण आहे हा सिलेंड्रिकल नाही आहे, सिमेट्रिकल नाही आहे. तर तुमचा नॉन सिलेंड्रिकल किंवा वी कॉल नॉन सिलेंड्रिकल म्हणजे सिंपली काय तुमचा हा राउंड शेप असेल तर वी कॉल नॉन सिलेंड्रिकल टाइप. ओके, सॉरी, सिलेंड्रिकल टाइप. सायलेंट पोल म्हणजे काय? अशा टाइप मध्ये. ओके, इथं एन पोल एस पोल वी हॅव सीन ऑलरेडी इन द इंडक्शन मोटर प्रिन्सिपल, इंडक्शन मोटर theory. So here the rotor do not have any windings wound over it, but the stator have two phase winding as shown in figure. Okay, so basically rotor doesn't have any type of winding, but stator has a two windings. I call this is this one. Okay, A dash and B dash. It's a part of the stator side. Okay, now it should be noted that in actual SRM, the number of phase winding on stator may be more than two. Okay, that means in a switched reluctance motor, the number of phase winding, okay, it may be more than, it may be two or more than two. Now, since the rotor is of silent construction, the inductance of stator phase winding varies with the rotor position. Because now you can see that. Now suppose माझा हा तुमचा एक वाइंडिंग इथं आहे, A डॅश एक वाइंडिंग आहे, B डॅश एक वाइंडिंग आहे, स्टेटरचं. ओके, सो सपोज माझा रोटर समजा आता ह्या पोझिशनला. Now what will happen? इथं माझं इंडक्टन्स मॅक्सिमम असणार ना, बिकॉज फ्लक्स इज पासेस फ्रॉम A to B और A to A डॅश. आता सपोज इथं एन पोल झाला, इथं एस पोल क्रिएट झाला, तर काय होणार? इथून ए पासून म्हणजे ए पॉइंट पासून रोटर मध्ये फ्लक्स जाणार आणि ए म्हणजे एन पोल इथं क्रिएट होणार आहे आणि एस पोल इथं क्रिएट होणार आहे. सो बिकॉज ऑफ दिस पर्टिक्युलरली सायलेंट पोल स्ट्रक्चर, व्हॉट विल हॅपन? The inductance of the stator phase winding varies with the rotor position. Now for this, okay, now here the inductance is here. Now what will happen? The inductance is minimum here. Okay, इथं सुद्धा काय inductance आता minimum आहे, because my rotor is for now for this position my rotor is varies or my rotor is rest at this position. Suppose my rotor is rest for this position, then I have the maximum inductance at point A point and A dash point. Suppose माझा rotor पूर्ण horizontal आहे. Okay, so I call that the rotor inductance has maximum at B and B dash point. Okay, now the inductance is minimum when the rotor axis and stator phase winding axis coincides, where it is a maximum when both axes in quadrature. That means here quadrature axis as well as the we call it as the this main axis and as well as the quadrature axis. Okay, or direct axis as well as the quadrature axis. Now here the inductance is minimum when the rotor axis and stator phase winding axis coincides. म्हणजे जर समजा इथं समजा माझं इथं समजा rotor position समजा इथं आहे. Okay, so suppose my rotor position B आणि B dash ला आहे आणि माझा flux suppose A आणि A dash ला असेल. So in that case my rotor positions are minimum while it is maximum with this A dash point. Now we see about the doubly silent construction. Now you can see that here single silent म्हणजे काय? इथं A dash B dash. Just check the difference of the stator side. The stator च्या construction वरून there are two types are met. Okay, switched reluctance as well as the this switch doubly silent or singly silent motors. Okay, so here singly silent motors are there. Now here doubly silent rotors are there. म्हणजे मगाशी फक्त single, you can see the difference in the construction side of stator. Now unlike singly silent type, the stator of doubly silent switched reluctance motor is of a silent construction and consists of 4 poles as shown in figure. There are totally 4 poles are there. The rotor do not carry any winding and is of silent construction but have 2 poles. Now you can see that the rotor doesn't have any type of winding, but it has a silent construction having a 2 poles. Okay, thus this type of switched reluctance motor is a heteropolar motor where the number of stator and rotor poles are not same. ओके, हेट्रोपोलर म्हणजे काय, जर नंबर ऑफ स्टेटर आणि रोटर पोल जर इक्वल नसतील तर दिस पर्टिक्युलर मोटर वी कॉल द हेट्रोपोलर. ओके, आणि जर दोन्ही सिमिलर असतील वी कॉल द बायपोलर मोटर्स. सो हिअर the stator poles are 4 but rotor poles are 2. Okay, the stator phase windings are concentrated winding. These concentrated windings are windings on radially opposite poles are either connected in series or parallel to result into two-phase winding on stator. That means these two windings. Now you can see that here dot connections are there, here cross connections are there. Here dot cross. Okay, so these stator windings are maybe connected in a series or parallel. That means opposite polar. म्हणजे A इथं काय करणार, A dash B B dash असं कनेक्ट करतात आणि इथं A dash B B dash. It may be connected in series or parallel depending on the connections. The motor phase to create the two phase winding. म्हणजे basically I require the two phase winding. मला स्टेटरला दोन फेज क्रिएट करायचं आहे. जर मला एकच फेज क्रिएट केलं तर काय होणार आहे, एकच फेज क्रिएट केलं तर मला कुठल्याही प्रकारचे टॉर्क क्रिएट होणार नाही, बिकॉज देयर इज ओनली वन फेज इज देयर. ओके, सो हियर to produce the two phase windings I require to either connect the either connect to in the series connection or the parallel circuits. Okay, now a doubly silent type switch reluctance motor or a variable reluctance motor produces more torque as compared to singly silent type for the same size. Therefore doubly switch reluctance motor is more common and widely used. Why there is torque is more in this particularly doubly silent construction? Because in the stator side we have made provision for the 4 poles. Okay, it's a 4 pole set, and similarly here more windings are there in the stator poles, and because of this only what will happen, the torque is more for the doubly silent constructions. Okay, our torque is the maximum because we have made the 4 pole construction for the stator side, and hence only because of this only it creates the more torque compared to the single silent construction, and hence this type of motor is most commonly used for industrial applications. Now this is a working principle of switched reluctance motors. Now as we know that the magnetic flux have a tendency to flow through a lowest reluctance path, therefore rotor always tends to align along the minimum reluctance path. This is the basic working principle of switched reluctance motor or variable reluctance motor. So what I said, it is a part of reluctance motor. Reluctance motor म्हणजे reluctance म्हणजे काय, it is opposition to the flow of fluxes. म्हणजे काय, मी काय सांगितलं इथं जेव्हा रिलक्टन्स टॉर्क क्रिएट होईल त्याच केसमध्ये माझा मोटर रोटेट होणार आहे किंवा रोटर माझा फिरणार आहे. ओके, सो वन्स as I know the principle is that magnetic flux has a tendency to flow through the lowest reluctance path. ओके, म्हणजे काय, रिलक्टन्स जिथं कमी असेल तिथनच तो फ्लो होणार आहे. Therefore rotor always tends to align along the minimum reluctance path. Now here you can see that. Now for this is nothing but a rotor part of the this reluctance motor, and this is part of the stator side. Okay, this is nothing but a stator side while this is the rotor side. Now when stator phase winding A is energized, the rotor align along this phase as shown in figure 1. That means here. Okay, now what will happen, suppose I am giving supply for the A phase. Okay, suppose my A he winding up B and is C. Okay, so totally I have the 3 different phase windings are in the stator side. Now at that time suppose I'm giving energy or supply to the particularly A phase, then what will happen here, and in the end pole the flux is produced. Now this flux is passes through this particular rotor. म्हणजे काय होईल, इतकं फ्लक्स तयार होणार ना, and as we know that the rotor this particularly flux is always passes through the low reluctance path. आणि हा जो रोटर आहे, हा रोटर कसा असतोय, तर रोटर इज मेड अप ऑफ द फेरोमॅग्नेटिक मटेरियल. ओके, म्हणजे सिंपल रोटर तुमचं काय असतं, तर रोटर मध्ये ऑलवेज इट इज हॅव्हिंग अ फेरोमॅग्नेटिक मटेरियल. सो जेव्हा तुमचा इथं फ्लक्स इथं तयार होणार आहे, सो द रोटर इज जेव्हा इथं फ्लक्स तयार होणार आहे, रोटर टेन्स टू अलाइन विथ दिस पर्टिक्युलर लो रिलक्टन्स पाथ. म्हणजे रोटर तुमचा जरी कुठेही पोझिशनला असेल तरी काय होणार आहे, रोटर तुमचा ह्या पोझिशनला येणार आहे. ओके, नाउ when stator phase winding A is de-energized and winding B is energized, म्हणजे इथं काय केलं, आधी मी इथं दिलं होतं, माझ्या रोटर पोझिशनला इथं आला होता, मग मी काय केलं, A चा सप्लाय बंद केला आणि B ला मी सप्लाय दिला. Now what will happen, now because of this only what will happen, now the rotor align itself along B बी फेज ऍज शोन इन फिगर. म्हणजे काय झालं बघा नाव, हा मगाशी एक वन पोझिशन तुमचा इथं होता कारण इथे मी सप्लाय दिलं होतं, त्यावेळी काय झालं मिनिमम रिलक्टन्स पाथ चूज केला. नाव व्हॉट विल अपॉइंट्स, आय एम स्विचिंग ऑफ दिस सप्लाय, आय एम स्विचिंग ऑन, इथं मी इथला सप्लाय बंद केला आणि इथे मी स्टार्ट केला. ओके, आय एम स्विचिंग ऑफ दिस सप्लाय and switching on this supply, I'm switching on the B phase. Now what will happen? These positions. Now, because of this energizing of this B phase, now this rotor is try to align on the B because of the low reluctance path. Okay, म्हणजे हा रोटर काय झाला, आता इथं होता, आता हा इथं गेला, because it is choosing the low rotor path, that is rotor is aligned with the this particular sectors. Okay, म्हणजे आधी normally इथं काय झालं बघा, रोटर पोझिशन इथं होता, you can see that now rotor is try to align on the B phase or B winding. Okay, similarly now here the rotor occupies a position along the phase windings when this phase is energized. म्हणजे काय झालं, again suppose I am giving supply to the C phase. Okay, now what will happen, again the rotor try to align with the C phase. म्हणजेच काय झालं, ज्या तुम्ही वाइंडिंगला सप्लाय, ज्या फेजला तुम्ही सप्लाय देतात त्या फेज मध्ये तुमचा रोटर इज ट्रायज टू अलाइन. दॅट मीन्स इन दॅट केस द रोटर रोटेशन इन nothing but a clockwise or anti-clockwise. For this figure it is nothing but an anti-clockwise direction. Thus the rotation clockwise direction is achieved by energizing the phase winding in A B C sequence. Please unmute your audio. Mute करायचं audio. ना ज्या ठिकाणी तुम्ही सप्लाय देत, ज्या फेजला तुम्ही सप्लाय देत आहे त्या केसमध्ये तुमचं काय होणार आहे, नाव वी विल गेट द रोटर पोझिशन्स. Okay, we will again we will start the meeting. Just time limit संपलेला आहे. It has only 40 minutes permissions for this conducting meeting. परत एक लिंक जॉइन करतोय, just join it again. We are basically we are in the basic, as we know that in the synchronous motor we are provided the field winding to produce the fluxes. म्हणजे आपल्याला माहिती आहे की synchronous motor मध्ये आपण field winding कशासाठी लावतो, तर to produce the fluxes. But as I said here, there is no any field winding on the rotor of PSM, that is a PMSM. That means permanent synchronous motor मध्ये कुठलाही टाइपचा रोटर नाहीये. So मला तर field winding जनरेट करायचं आहे. So for creating the field poles I should use a permanent magnet, because synchronous motor always required the stator as well as rotor. In the rotor side I should always require the field winding for its synchronous operations, and synchronous operation if possible it is only once this synchronous speed is achieved. म्हणजे नॉर्मली सिंक्रोनस मोटर इंडक्शन मोटर सारखं स्टार्ट करतोय, बट मला सिंक्रोनस स्पीडला आणायचं असेल तर आय शुड अप्लाय द एक्सायटेशन, वी कॉल इट डीसी एक्सायटेशन. ओके, so these field poles are created by using the permanent magnet. These permanent magnets are made up of high permeability and high coercivity materials like samarium cobalt and neodymium iron boron. Okay, this neodymium iron boron is the most used due to its ease of availability, easy availability and cost effectiveness. Basically this permanent magnet, this we call is high permeability. High permeability म्हणजे simply काय, it permeability is a property of this producing the fluxes as well as passing the fluxes. Okay, so this permanent magnet has a high permeability to achieve the high fluxes during its operations. Based on the mounting arrangement of the magnet on rotor core, permanent magnet synchronous motor can be categorized into two types. First, surface mounted permanent magnet synchronous motor and buried or interior permanent magnet synchronous motor. That means it has again two types. I just important is that there is no any field winding on the rotor side of this permanent magnet. Now we will see about the construction of the permanent magnet synchronous motors. Here the as I said, there is a two types. First is we call it the surface mounted permanent magnet synchronous motor. The permanent magnet is mounted on the rotor surface. Okay, that means according to this part of permanent magnet position, the motor is classified into two types. I call it surface mounted permanent magnet as well as a buried mounted or oriented mounted. So in the surface mounted permanent magnet motor, the permanent magnet is mounted on the rotor surface. I show you here. That means here, this is part of the rotor. आणि रोटरच्या वरती मी काय केलं, मॅग्नेट प्लेस केलं. यू कॅन सी दॅट. ओके, हा तुमचा पूर्ण रोटर आहे. रोटरच्या वरती किंवा ओव्हर द रोटर कन्स्ट्रक्शन आय हॅव माउंटेड द permanent magnet. Okay, so this type of PMSM is not robust and therefore not suited for high speed applications. Since the permeability of magnet and air gap is almost same, therefore this type of construction provides a uniform air gap. Because as you know that this uniform air gap कसा achieve होणार आहे, because मी पूर्ण माझा स्टेटर तरी पूर्ण माझा सिमेट्रिकल आहे पूर्ण हा, as well as stator symmetrical किंवा पूर्ण cylindrical shape आहे आणि rotor पूर्ण cylindrical shape आहे. Okay, so what will happen, because of application of the permanent magnet, what will happen, there is uniform air gap takes place. air gap कुठे असणार आहे, it is the gap between stator and rotor. हा पूर्ण cylindrical shape आहे ना इथं. So in that case we will achieve the uniform air gap in between the stator as well as the rotor part. Now this type of PMSM is not robust and robust. Why robust nahi hai? Because I have mounted the permanent magnet on the surface of this particular rotors. Okay, therefore there is no reluctance torque present. Because of only I have provided the this particular permanent magnet here. So magnets are there, म्हणजे flux असणार आहे obviously ना. Reluctance torque का create होणार नाही आहे, तर मी तर मगाशी काय केलं, तर माझं वाइंडिंग पण होतं आणि तर मॅग्नेट पण होतं. But here what will happen, I put the rotor, I have put it this particularly reluctance, sorry, I have put it the magnet on the surface of this particularly rotor side. So because of the permanent magnet, so the flux is created. Now if the flux is created in the rotor side, and because of the flux interaction between the rotor flux and stator flux, now stator जो सप्लाय देणार त्या काय स्टेटर मध्ये फ्लक्स तयार होईल, तो फ्लक्स आणि रोटरचा फ्लक्स, रोटर फ्लक्स कुठला, हा परमनंट मॅग्नेटमुळे फ्लक्स, हे दोन्ही फ्लक्स एकमेकाला इंटरॅक्शन होतील and hence the torque is exerted on the this particularly rotors. Now we will see about the second part, we call the interior or buried permanent magnet synchronous motor. This type of permanent magnets are embedded into the rotor instead of mounting on the surface. Previously it was mounted on the surface, but right now we have mounted this particular rotor inside the rotor. म्हणजे इथं काय केलं, buried आहे. Buried म्हणजे काय, आतमध्ये फिक्स करणं होत नाही. ओके, रोटरच्या कोर मध्ये I have put it in the rotor core, I have put it this particularly this permanent magnets. Okay, this provides robustness and hence can be used in high speed applications. Due to presence of saliency, reluctance torque is present in this type of permanent magnet synchronous motors. So what will happen here? Now you can see that I have put this particular magnet on the rotor core. ह्याच्यामध्ये मी put केले. Now what will happen here? Rotor fluxes are there, but it is restricted by this particular magnets. So here this torque is created because of the reluctance only. Okay. So this is part of the construction side of permanent magnet synchronous motor. Now we will see about the working principle of permanent magnet synchronous motors. The working principle of this motor is same as that of your synchronous motors. When three-phase winding of stator is energized from a three-phase supply, rotating magnet is set up in the air gap. Okay, that means when we give the three-phase winding, when you are giving the three-phase supply. Please unmute your audios. Sir, mute करें sir, please. Now, the working principle is similar to that of a synchronous motor. When three-phase winding of stator is energized from three-phase supply, rotating magnetic field is set up in the air gap. Okay, so here at synchronous speed, the rotor field poles locks with the rotating magnetic field to produce the torque, and hence rotor continues to rotate. That means what happens? So here, as I said, I have put it the permanent magnet. Permanent magnet काय करणार आहे, तो फ्लक्स क्रिएट करणार स्वतःचा, आणि इथं मी स्टेटर मध्ये फ्लक्स कसं तयार होणार आहे, बिकॉज ऑफ द थ्री फेज सप्लाय. ओके, सो बिकॉज ऑफ these two fluxes, the interaction of the fluxes is takes place in the motor itself, and because of this only, what will happen? The rotor is start to rotate. As we know that the synchronous motor are not self-starting, the permanent magnet synchronous motor needs to be started somehow. That means similar to the synchronous motor, it needs to start with the help of any external devices. Since there is no any winding on the rotor, induction windings for the starting is not applicable for such motor. Okay, that means as we know that we are starting the synchronous motor with the help of such type of we are starting this synchronous motor like similar to that of induction motor. म्हणजे आपण इंडक्शन मोटर सारखं सिंक्रोनस मोटर स्टार्ट करतोय, त्याच्यानंतर आपण जेव्हा सिंक्रोनस स्पीडला येतो तेव्हा आपण we are switching on the excitation. But here what will happen, as I put this permanent magnet on the rotor side, then this type of motor should not start similar to the induction winding, induction motor. Induction motor तुम्ही start directly करत होता, but for this this particularly permanent magnet synchronous motor doesn't have any type of winding. Hence, a variable frequency power supply should be used for switching or for starting these motors. Okay. Now we will see applications. This type of motors can be used as an alternative for servo drives. That means servo motors now basically they have used in a lot of industrial applications. Now here, this type of motors are replaced to the servo drives because of its various advantages. Okay, so these type of motors are used where servo motors are used or servo drives are used, and it is widely used in various industrial applications where robotics, fraction, aerospace. Okay, so as we know that for the robotics, as we are using a lot of these servo motors are there, or we maybe there may be AC servo motor, or maybe there may be DC servo motors, but these type of servo motors can be replaced with the help of these permanent magnet synchronous motors. जिथं मला servo motor वापरणं शक्य नाही, in that case I will use this type of motors. Okay, so thank you for attending this particular lecture. So for next lecture we will see about next type. Okay, so just give attendance. I have taken the screenshot of your presence, and if you have any doubt regarding the this permanent magnet synchronous motor as well as this switch reluctance or synchronous reluctance, please free to ask. जर तुम्हाला काही doubt असतील तर you can ask freely. जर तुम्हाला काही डाऊट असतील तर प्लीज यू कॅन आस्क. Okay, fine. That's it from this lecture. Now for tomorrow or next day, we will in the next lecture we will see about the remaining part of this particularly topic. Okay, thank you for attending this lecture.